All right, today we are going to be talking about
Teachers, please excuse the interruption. If you would double check that email that I sent out for all testing people and send them to 13105 at this time. All those who need to do that one session of makeup testing, send them to 13105 at this time.
Pythagorean Theorem and its converse. Pythagorean Theorem and its converse. States in a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So let's take a look at a right triangle here. In a right triangle, obviously you have one right angle. You have vertices, we're going to go A, B, and C. Now, if our vertices are A, B, and C, then the sides opposite each vertex are the lowercase same letter or respective letter. So opposite of vertex C will be lowercase c. Opposite of vertex A will be lowercase a and lowercase b for the third side. And what the Pythagorean theorem says is that if triangle ABC is a right triangle, then side A squared plus lowercase b squared equals lowercase c squared. These two sides here that form the right angle, those two sides are called legs. The third side of a right triangle, the side that's opposite the 90-degree angle, all right, that's called the arm. You've got the legs, then you have an arm, okay? I hope you didn't write that down. It's not called the arm. It's called the hypotenuse. I thought that was funny. That wasn't funny? Arm, leg, get it? Legs, arm. Get it? Body parts? Not funny though? Okay. It's called the hypotenuse then. The delivery? Delivery was off? I'll work on it. Okay. So we've touched on this year, but now we're covering it officially. How have we used this so far this year, this Pythagorean theorem? Anybody tell me? Anybody that's been here this year? Yeah, Matt. He said we were using it to find out how long this hypotenuse was, right? Anybody remember using it? Remember we were using it instead of the distance formula to find out how far a diagonal or how long a diagonal was on the coordinate plane? We've done that a few times, right? All right, well, this is the official formula right here. This is the Pythagorean theorem and its converse. So what we're going to be doing today is we're just going to be finding missing side lengths in triangles. So right here for the next couple problems, we're going to find x. Ready? Find x. So here's a triangle. Here's a right triangle. We got a 6, we got a 15, and we got an x. Now, if you need to, label the sides. The two sides that form the 90, those are A and B. The side across from the 90, that's your side C. So in this problem, we got 6 squared plus 15 squared equals x squared. So that is 36 plus 225 equals x squared. And 36 plus 225, 261 equals x squared. So we're going to find the square root of each side. So the square root of 261 equals x. And then we're going to simplify that square root. So I'm going to start dividing it by perfect squares. Remember our perfect squares from yesterday? We don't use 1, but we got 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. All right? So some of you will be better at this than others. The 261, let's go 261 divided by 4. Doesn't go. 261 divided by 9. All right, 9 goes 29 times. Now, let me show you something for some of you guys that understand what's going on. All right, square root of 261. If the square root of 261 is equal to the square root of 9 times the square root of 29. 9's a perfect square, right? Now, pay attention to this. You see this 29 here? Does that 29 have any perfect square factors? Does 4 go into 29? No. Does 9? Does 16? And 25? Okay, look. If a perfect square goes into what you're factoring a number of times that doesn't have a perfect square factor, then the 9 is the largest perfect square, and you can stop. Okay? And hopefully I can show you an example of what that looks like when you need to keep dividing. All right, so what does this simplify to here? Good. 3 radical 29. All right. So our x is equal to 3 radical 29 is equal to x. All right, let's do that again. That was fun. Here's another triangle. We got an 11. We got an x. We got a 9. Label the sides. Here's side A, side B, and side C. So now we've got x squared plus 9 squared equals 11 squared. So let's square everything. So x squared plus 81 equals 121. Now pay attention here. This is a little bit different. We got to subtract 81 from each side. So our x squared is equal to 121 minus 81. That's 40. We square root both sides. So x equals the square root of 40. And 40's got a perfect square in it. So our x is equal to the square root of 4 times the square root of 10. So our x equals 2 radical 10. Simplest radical form. Any questions on any of those steps? Okay. A Pythagorean triple is a set of 3 non-zero whole numbers A, B, and C such that A squared plus B squared equals C squared. Pythagorean triple. Pythagorean triple. 3 whole numbers. A squared B plus B squared equals C squared. That's the key to a Pythagorean triple and the definition. Got to be 3 whole numbers. 3 non-zero whole numbers such that A squared plus B squared equals C squared. So an example of a Pythagorean triple would be 3, 4, and 5, because 3 squared plus 4 squared equals 5 squared. That's 9 plus 16 equals 25. That makes 3, 4, 5 a Pythagorean triple. All the numbers have to be whole. None can be 0. And the sum of the squares of the two smaller ones have to equal the square of the larger one. Another example is a 6, 8, and 10. 6, 8, and 10, that's a Pythagorean triple. If you ever see a triangle and you know that 2 of the sides are 3 and 4, the hypotenuse is going to be 5. If 2 of the legs in a triangle are 6 and 8, the hypotenuse has got to be 10. Okay? Pythagorean triple, 3 non-zero whole numbers such that a squared plus b squared equals c squared. All right, 10, 24, 26. There's a long list of them. All right? But the only thing you need to know about Pythagorean triples for your quiz is that it's 3 non-zero whole numbers such that a squared plus b squared equals c squared. It's not just the 3 sides of a triangle, okay? Because if you go back here, you know, is 2 radical 10, 9, and 11 a Pythagorean triple? Well, it meets the criteria of a squared plus b squared equals c squared, but 2 times the square root of 10 is not a whole number, is it? Is it? No, it's decimal. It's a decimal. Square root of 10 is a non-terminating, non-repeating decimal. So a non-terminating, non-repeating decimal times 2 is just a twice as big non-terminating, non-repeating decimal. All right? Y'all got that? Very good. Very good. Okay. Converse of the Pythagorean Theorem. States if the sum of the squares of the two shortest sides of a triangle equal the square of the third side. If the sum of the squares of the two shortest sides of a triangle equal the square of the third side, what am I going to say next? What am I going to write next? Then, good. Good. Then the triangle is a very good, is a right triangle. So you can also use the Pythagorean theorem to determine if a triangle is a right triangle or not. So if you are given a triangle, let's say you got a triangle ABC and it's got some leg lengths, all right? Let's say it's got a 10, a 12, and a 23. and you're asked if it's a right triangle. You say, I don't know. Right? But then you could say, okay, well, wait a minute. The converse of the Pythagorean theorem states that if the sum of the squares of the two shortest sides, okay, so if 10 squared plus 12 squared equals 23 squared, then it's a right triangle. So that's 100 plus 144. Does that equal 23 squared? That's 529. Ooh, no way. Does 100 plus 140 equal 529? No, does not equal 529. Is this a right triangle? No, this is not a right triangle. It's not a right triangle. Okay? Now, here's what you do need to know. Okay? This is how you can classify triangles using the Pythagorean theorem. If a squared plus b squared is greater than c squared, the triangle is acute. If a squared plus b squared is greater than c squared, the triangle is acute. If a squared plus b squared is less than c squared, what kind of triangle is it? Obtuse. Good. If a squared plus b squared is less than c squared, then the triangle is obtuse. So this triangle that we just did, it's not a right triangle, is it? What is it? It is obtuse. And if we just said this, that if a squared plus b squared is equal to c squared, what we got here? Very good. The triangle is right. The triangle is right. All right, I got one more example to cover, and then I'm going to give you some practice to do, because I know that's what you're wanting right now, right? Some practice problems. You're thinking to in your head, boy, I really want to take these concepts I learned and I want to practice them now on my own. Is that what everybody's thinking? Good, good. So here's the type of questions you're going to see. Determine whether each set of numbers can be the measures of the sides of a triangle. If so, classify the triangle. Determine whether the numbers given can be the sides of a triangle. If so, classify the triangle. Let's start with 6, 13, and 20. 6, 13, and 20. Determine whether the numbers given can be the sides of a triangle. Can 6, 13, and 20 be the sides of a triangle? We did this a couple weeks ago. Remember, we took the two smallest sides and we added them and subtracted them, right? So if you add the 6 and the 13, you get a 19, and if you subtract them, you get a 7. So can 20 be the third side? No. So first of all, you just write no. Can't even be a triangle. It's not a triangle. Okay? So let's try 7, 14, and 16. 7, 14, and 16. All right, 7 plus 14 is 21. 14 minus 7 is 7. So our range for the third side is between 7 and 21. So this can be a triangle. And then we do 7 squared plus 14 squared. And I put an open box there. And I put 16 squared. And then in your calculator, this is a nice little feature. You can push 7x squared plus 14x squared and hit equals. So this left side equals 245. And then you can push 16x squared, and that's 256. All right, and in this case, our a squared plus our b squared would be less than c squared. So Vince, what we got? Obtuse triangle. Obtuse triangle. Y'all get the idea? And now make sure, look, that you got these numbers were all in order. Small, medium, large, small, medium, large. If you get something like 9, 42, 35, the first and the last now are the two smallest, aren't they? Okay, so 9 plus 35 would be 44, and 35 minus 9 would be 20 something, so 42 would work. So this would be a triangle. And when you set this up, you got to do 9 squared plus 35 squared and compare it to 42 squared. So shortcut on the calculator, 9x squared plus 35x squared equals, that's 1306 on the left. 42x squared, that's 1764 on the right. And that's a less than again, and that's obtuse again. Good, good. Any questions on anything we covered today? Good material, huh? Starting to work into this is like my favorite part of the whole book and the whole class. Pythagorean Theorem. And we're going to go into trigonometry, sine, cosine, and tangent, special right triangles. All that good stuff's coming up. I get really excited about this time of the year. All right, so let me give you some practice problems to do. In your workbook, page 99. We're going to do 1 through 18. Then on page 100, we got 1 through 17. 1 through 17. And then we're supposed to check focus for homework. All right. And guys, it's important that you complete these assignments, okay? The idea behind giving you a fair amount of problems is two reasons. One is by repeating the same types of problems over and over and over as you're doing them. All right, what happens is you have to look at your notes less and less and less because you learn how to do the problem. Okay? After doing yesterday's assignment, by the time you did all those problems, if you would have done all those problems, you wouldn't have been looking at your notes at the end of the assignment to see how to do the problems. Okay? That's the idea, is if you do that, then by the time it gets to be Friday, this stuff is just easy for you. You've done all of these problems so many times, they're easy. But if you play on your phone the whole period and you do some of this other BS that you guys do in class, you sleep or you put your head down or you tell me you do your work at home and all this other garbage, then the quiz is really hard on Friday. And next thing you know, you're not doing very well in the class and you're emailing me going, how can I bring up my grade? Well, you can bring up your grade. You can start it now by doing all the work that I assign every day that I assign and do it in class right now while it's fresh in your minds. Does everybody understand that? Great, great. Been a great first block this morning. One of my favorite ones yet this year. Okay, so as one of my favorite comedians would say, going out there now, get her done.